Hi everyone, welcome to my YouTube channel. Today my topic for this video is the object-oriented programming language. So as you remember in the previous video, I thoroughly discussed about the class, how we create the class, naming convention of the class, how we define the member of the class like the public members, private members, how we use the double underscore init methods into the class, and how we call the class, like how we create the objects by calling the class during the run times, how we initialize the class, and then also how we call the multiple methods from the class. So these all things I already discussed in details in previous video. So in this video, I'm using the same collabs. Here I'm adding the more details regarding to the object-oriented programming language. If you want to get the more details regarding the basic of the class, how we create the class, how we define the public variable, private variable, constructor into the class, and other methods, then you can refer to the previous videos related to the class I created. You can find on my YouTube channel. Let me move to this video. This video is specific to the object-oriented programming language features, which is supported by the Pythons. So before proceed further, I will discuss the self and in details again. In the previous video, I discussed the self, but here I want to recap the things and before moving further. So self basically the extra parameters we pass into the methods, like in the class we create a methods. Into the method we pass one extra parameter, those parameter called the self. And while calling the class, we didn't pass value for the self. Suppose we have the methods take no argument, then we just use the self for those methods. And let me show you how we use this. You can see here, like the get card details as shown in this image, we are just passing the self because this method is using no argument. So we are just passing the self here. And in case of init, you can see here, we are passing the self, then the other attributes. So this way, like we pass the self. And suppose if we want to compare the Python in with the C++ and Java, then we can compare, okay, self is similar to the pointer in C++ and reference in Java. And when we call a methods, for example, let me show you. So here in this image, you can see here I'm calling the above class, like this is the class we created car, and then we call this class car. These are the attribute values. And then the object name, you can say car instance data is the object name. We create a object by calling the car class here. And then we call the method from the class. You can see here, get car detail is the one of the methods inside the class. And this method basically printing the details related to the car. So here we are calling this method. You can see here, this is the object name and then calling the methods. So once we call a class, and then the method is created into the memory. Suppose this is the memory. Let me take the example. So here, you can see here, this is the memory and this is the object. You can see here, like the object is created once we call the class. And once we call the method from the object, you can see here, this is the object which is created into the memory. And this is the method from the class we call with the arguments here. And in our example, this is the object we created in above image. If you remember, let me show you. You can see here in this image we create, this is the object and this is the method we call. And this method is not taking any argument. That's why we pass no value here. This bracket is blank. So you can see here similar to above example. You can see here we are calling the methods in the backend. You can see here how the Python is work into the backend. This is the class name, then the method name, which method we call here. You can see here, okay, this one is the method name. So this is the method name, and this is the object. You can see here object which is created by calling the class. So this is the object name and then the parameter which we need to pass. And in our case, like this is the object name. So in our case, like the class name, then dot, then method name, get underscore car underscore detail is the method name. You can see here, this is the method name and this is the object name. Car underscore instance data is the object name. If you remember, this is the object we created, like the car underscore instance underscore data while calling the car class. So this is the object, and by calling the method get car details from the object. So this is the way how we call the object from the class. And in the backend, how self is work, how Python is used the self. So in the backend, this way, like the class name is go for the execution, then the method name, class name, dot method name, then the object name for the reference purpose. And this is managed by the self. And next one is the double underscore init. Double underscore init, I already discussed in details in our previous video. If you have any doubt, you can refer to the previous video also. So basically the init method is a constructor. And if we compare the Python with C++ or Java, then in the Java and C++ also we have the constructor. And same way in the Python, double underscore init is the constructor. And it basically execute while we call the class. During the initialization, when we create a object in and when we call the class, then this method is executed and is initialize all the attributes during the initialization time. So that's all about the init and self. Let me move to the today agenda is object-oriented programming. So we know the Python is for all the features like the standard features of object-oriented programming. First one is and most important part is inheritance. Inheritance basically a class mechanism in Python to inherit variables, methods, functions from one class to another class. Suppose we create a one class, we define the variable in one class, created the function in one class, and then we create another class. We want to reuse the functionality which we already created and class. Then we inherit those class to the new class. So in inheritance, the base class which we want to inherit, those class called the base class or the parent class, and the subclass or the child class which inherit the variables function from the parent class or base class called the derived class. So base class and the parent class are same, both the terminology I'm going to use here, like the base class and the parent class for same purpose. And the derived class and child class is the same terminology. And let me show you with the help of drawing here. Suppose this is the parent class and this is the child class. And I created all the variables, like I define all the variables functions in the parent class. And here I want to reuse those code. So I basically inherit the parent class. So like this is our base class. We can say this is the base class or the parent class, both the terminology used for this class. And for the derived class, we use the terminology derived class or the child class, where we inherit the data from the parent class. So this way inheritance is work into the Python. And further, class inheritance mechanism allow multiple base classes. Yeah, it's depend upon like the requirement. We can inherit data from multiple base classes also. And we can drive class like a drive class can override any method from its parent class, or you can say the base class. Like suppose we have the different requirement, we want to add some other parameters into the existing class functionality, then we can override any functions, any functionality into the child class. And I will show you the real-time example also. And a method can call the methods of base class with same name. And we can call the method with same name also. And object can contain arbitrary amount and kind of data. And object I already covered in detail in the previous video also, where I covered the thorough details regarding the objects. Objects basically the collection of variables, attributes, and it contain multiple type of data and functions. And same things is mentioned here. And as is true for the modules, class is dynamic in nature. Class basically created once we call the class. During the object creation, we call the class, then class create into the memory. So these things we already know. And further, two built-in functions we generally use into the inheritance. First one is each instance. This is basically used to check the instance type, like this particular instance, this particular object is belong to which class. And this is the syntax, like the each instance, then the object name, and then the type name. And it will return true if object class type is int, otherwise it return false in this example. And if we pass here the string, then it check, okay, object type is string, then it return true, otherwise false. And another method which is commonly used in inheritance is each subclass. To check the inheritance, like the each subclass, this is the syntax, this is the child class, and this is the parent class. Here is the bool is the child class in this example, int is the parent class, and it return true if bool is a subclass, like the subclass inherited class from the int. If we inherit int into the bool, then it's written true, otherwise it return false. But as we know, like the float is the different class, is not a subclass of int, that's why it's written the false. So next is the type of inheritance. So let me move the type of inheritances. And first one is the single inheritance. Suppose we have the single parent class and we inherit those class to the single child class. So let me show you in the image. This is the example of single inheritance. This is the one parent class and one child class. You can see here, this is the parent class and this is the child class. So we are inheriting one parent class to one child class. This is the single inheritance. So next one is the multi-level inheritance. In multiple level inheritance, basically we have the classes on multiple level. Suppose we have the first class as shown here. This is the parent class at the top level. And then we have the sub-parent on the level 1. And then we have the child class on level 2. So here basically, first we are inheriting top parent class to the child class on level 1. This is the sub-parent, you can say here. In sub-parent, we are inheriting the parent class from the top level. Then on the child level, we are inheriting the sub-parent. You can see here, this way. You can see here, this way we are inheriting the sub-level class to our child level. So this is the example of multi-level inheritance. Like that, suppose we have the three classes. One is the top class on the top level is the base class, parent class. Then on the level 1, we have the sub-parent. And in the sub-parent, we are inheriting class from the top level as shown here. And in the second level, we are inheriting class from the sub-parent level. And in the backend, like our child class is inheriting the sub-parent, and then the sub-parent is inheriting the base parent, like the top level class. So this way, like the multi-level inheritances work. And we can call all methods in the hairs, like in the child level 2, we can inherit all the methods from the parent class, from the base class also, all the method from the child class also level 1. So this way the multiple level inheritances work. And so next one is the multiple inheritance. In case of multiple inheritance, suppose we have the multiple parent classes. This is the parent class 1, parent class 2, parent class 3, and we have the single child class here. You can see here, this is the single child class. So this is the example of multiple inheritances. Next one is the hierarchical inheritance. Suppose we have the one parent class as shown here. You can see here, this is the one parent class and multiple child class. This is the like the child class 1, child class 2, child class 3. So this is the hierarchical inheritance. So these are the 4 type of inheritance in Python. First one is the single, then the multi-level, then the multiple, and then hierarchical inheritance. I move to the coding example. So here I am basically creating a class Tata Cars and inheriting the car class which we created above. Let me show you the car class first. So you can see here, this is the car class, and this class contains the 3 functions. First one is the double underscore init, like the constructor. Then we have the get car details method. Then we have the get car name method. 3 methods defined in this class, base class. And here we are inheriting the base class. And first we are creating the constructor here. You can see here double underscore init, then passing the self, as I already explained why we require the self. then all the attributes required by this function, and then initializing the attribute. You can see here by using self, and I'm inheriting the init constructor from the base class also. You can see here car double underscore init, then self car name, car model, car brand. Basically, this is inheriting the init from the base class. From here, you can see here I'm inheriting this constructor here. You can see here this is the way how we inherit. Defining the class, I pass the class name here, car, and then inherit the functions. Car, the base class name, then dot, then function name. You can see here this way I am inheriting the init method. And here I'm creating another function. You can see here function name get car details, and you can see here this is the same name in the base class also. Like in base class also we have the car get car details method, and similar way I'm creating here also like the get car detail function. Basically I'm modifying the function which inherit from the base class. Like the base class we have the get car detail functions, but here I'm creating a new function, and basically I'm modifying the overriding the existing function here. So this way we can we can inherit the existing functionality from the base class. We can modify the functionality from the base class also. Here are the two examples. In this example, I am basically inherit like the reusing the init as it is, and here I am overriding the function. You can see here these two examples. Further, let me move to the call. So this is the object I created by calling this child class, which I created here, and then I'm printing all the details. So this is the function which I call from the child class, and this is the function which I directly inherit from the base class. Because you can see here in this class I didn't create here get car name function. You can see here get car name, but get car name is coming from the base class. Let me move to here. You can see here this is the base class, and here is the function get car name, and this is as it is coming into the child class. So you can see here, if I run this code, it's printing. First, it's printing this car name is Tata Safari model, this one, then manufactured by Tata, country, India, color, black, and price. This is the new features which I added here. You can see here color and price added into the get car details while this function overriding. And the car name, you can see Tata Safari. This is coming from the base class as it is. So here is the example. In this example, I'm modifying the function in the child class, and here I'm using the as it is inherit function from the base class. And let me show you how this function work into the base class. So here I'm creating another object by using the base class, and now I'm printing the get car details similar function from the base class and the get car name both function. And you can see here it's printing the details from the car details from the base class as it is. You can see here car name, model name, manufacturing, in country, state, and the car name is same. You can see here car name is same in both the case, but the details in the end is different because these detail I added into the child class, and these details coming from the parent class. Let me show you. In the parent class, you can see here these two parameters is coming, but in the child class, we have the new parameters. So this is the way how inheritances work into the Pythons. So next one is the polymorphism. Polymorphism basically means we can use the same function or same interface in multiple formats. As I show you in the inheritance also, I use the get car details 2 times in the different way. In one time, I added the different attributes. In second time, different attribute. Similar way, we can use the polymorphism. And here are the example. I create a function to get the details related to like the car, either is the electric car, hybrid car, or diesel car. So you can see here I'm creating it to example with this code. So here first I'm creating a class is car details, and in the car details, this is the init methods. This method basically the constructor. So this already I discussed in details. And then I have the one function is the car name, and it's printing the names which we pass here in the init method. So this is the name of the car, is printing the name of the car. Then the second function is printing the type of the car. And so you can see here in this function type car, I'm printing my car is a diesel car. And this is the parent class for this example. You can see here car details. Now I create another child class. You can see here, this is the child class one, you can say electric car. So here I'm creating a child class, name of the class is electric car, and inherit the base class, this car detail class. And here basically I'm creating the function with same name, type car. You can see here in the base class also we have the function type class, and I'm again creating another function here. Basically I'm overriding the function from the parent class, and here I'm passing the print statement. You can see here my car is electrical car. And similar manner, I'm creating another child class is hybrid car, and inherit the base class. You can see here base class, I'm inheriting this class function again with same name type car, and changing the print statement. My car is hybrid car. So this way I can use the same functions type car in three ways. You can see here, this is the example of polymorphism, how we work into the industry. So this is the toy example. And first I'm creating a object by calling the base class car details, and then passing the name of the class is Thar. Then creating another object child one by calling the electric car class. Then creating another example by calling the second class. You can see here, this is the way how I create the three objects. One object from the parent class, second object from the first child class, third object from the second child class. And let me first print the parent object functions. You can see here I'm calling the name car function from the parent class and type car function from the parent class. And this print, I have a Thar, my car is diesel car. You can see here in first call this is printing. And if I call child object and call same function from the child object, name car and type car, it's printing I have a Thar. Again this is the same because this is calling from the base class. This function is same on every call because this is inheriting from the base class, but the second function is changed. You can see here second function is printing now my car is electric car. You can see here now this function is running. So this way like the polymorphism is work. And in the second example you can see here this printing my car is hybrid car. So this way we can use the same function in multiple ways, multiple forms. So this is the example of polymorphism. And next one is encapsulation. So encapsulation is a fundamental concept of object-oriented language. It's basically used to hide the data, like to hide the private data from the unauthorized access, from the verification. So in the industry, we use the private variable. I discussed the private variable in thoroughly in previous video also, but here I am discussing the private variable, protected variable again from the encapsulation point of view, how we can hide the data inside the class. Suppose we have the requirement in the big software to make a data type which modify or use inside a functions inside a class, and we can't provide the access to the end users or to the other classes to modify those data. So this way we can use the encapsulations, and we can use the private variable like the private member of the class, which I already discussed during our previous video. Here I am again came back to the protected and the private variables. So here I'm creating a new class car and cap, and I'm creating the three attribute. First one is the public members of the class. This is the public variable, you can see here. Second one is the private variable, and for the private variable we have the prerequisite requirement to provide the name start with the double underscore. So as highlighted here, I'm start this name is double underscore. So this is the private variable, and this variable accessible only inside this class. If we try to access this outside the class on any function and on any module, then this method, this variable is not accessible. So this way we can hide this data from the outside unauthorized access, and we can we can use the encapsulations here by using the private variable. And next example is the protected variable. Protected variable basically start with the single underscore. So in case of private variable, we need to define a variable name with the double underscore. In case of protected variable, we need to define the name with single underscore. And protected variable is accessible outside the class. Only the private variable is limited access, like we can't access the private variable outside the class. But for the protected variable, we can access those data outside the class. And here I'm using the init method. So this is the same as I use in the previous class also. And this is also the same method which I use in the previous class also, like to printing the card details. So I'm moving further. So here I'm creating an object by calling this class. You can see here, this is the class. These are the attribute I'm passing to the class during the initialization. And now I'm creating this object. You can see here. And if I call the public variable, this is the public variable. And if I call this public variable object dot public variable name, this is accessible outside the class. You can see here, this is printing. Now I call the protected variable. You can see here, this is the protected variable. Name is Pachkulla, and underscore city underscore class underscore protected var is the name of the variable. So this is also accessible outside the class. But if we move to the private variable, which starts from the double underscore, like the double underscore state underscore class underscore private variable, then this is not accessible. So here we provide the hiding capacity to hide the data from the unauthorized access. So this way we can use the private variable into the object-oriented language. So this is the way how encapsulation work into the Python. So this is the basic about the object-oriented features supported by the Pythons. On this particular video, I cover the inheritance, I cover the polymorphism, I cover the encapsulations. And so this is the main features we use into the industry while developing the like the industry level big softwares. We generally use the inheritance and the polymorphism we generally use. And that's all regarding the object-oriented programming. If you want to try this code, you can directly access this collab from the description of this video. I will put the link of this collab into the description of this video. And further, I will create another video for the meta class. So in the case of, if we discuss the optimal programming into the Python, there is the one mechanism is the object-oriented programming. Another one is the meta class also, how we can create a meta class also to make the optimal solution. So in the next video, I will discuss the meta class. So that's all about the OOPS into the Python. And thank you for watching this video. Please like and subscribe my channel. And thank you.